Hello and welcome to another section of our WAEC walkthrough. Today we'll be answering questions from the 2024 Theory Chemistry WAEC. Okay, so the first question is, what is an electrochemical cell? Okay, so we can answer this by saying an electrochemical cell is a set of consisting of two half cells. Okay, one is the oxidation half and the reduction half. Oxidation and reduction. Okay, in which chemical energy is converted into electrical energy. Okay, through redox reactions resulting in the flow of electrons. Okay, so the key words here is electrochemical cells involves oxidation and reduction. Those are the two half cells. Okay, so we have the oxidation half and the reduction half. And another thing that should also be in your definition is that it involves the conversion of energy from chemical to electrical. Okay, so when these two things are in your definitions, you are giving accurate definition, and also the flow of electrons or electric current. Now, the next question is the difference between an electrochemical cell and electrolytic cell. Okay, so a befitting way to answer such questions is by drawing a difference table, a table to show difference, where let us make this side our electrolytic cell and this side our electrochemical cell. Now, the difference number one. In electrolytic cell, energy is being converted from electrical energy to chemical energy. So we can say electrical energy is converted to chemical energy. While reverse is the case for electrochemical cell, here chemical energy, just as we saw in the definition, chemical energy is converted to electrical. Okay, so another difference is that the cell consists of only one single half cell for electrochemical. Okay, so we can say consists of only one half cell reaction. While for electrochemical, it consists of two half cells of two half cell reactions. So we have the oxidation and reduction half. Now, the third difference is that electrolytic cell is non-spontaneous. Okay. The reaction is non-spontaneous. That is, it will require an external force for it to proceed. While for electrochemical cell, it is spontaneous. It is a spontaneous process. So that means it happens voluntarily on its own. Okay. Now the next question says, explain briefly what will be observed when powdered zinc is added to a solution of copper to tetraisosulfate 6 in a beaker. Okay, so we can answer this by saying when powdered zinc is added to a solution of copper to tetraazosulfate 6. Okay, the blue color of the solution gradually it will gradually fade and a reddish brown deposit of copper is formed. Okay, now the zinc will dissolve to form zinc ion, dissolves to form zinc ion. Okay, now this is because zinc being more reactive than copper would displace the copper in the copper to tetraazosulfate. Okay, so we'll just say to displace the copper from the solution. Okay, so we know our reactivity series. Okay, reactivity series tells us how much a particular metal, for example, is more reactive than the other. So if we find two metals in an equation, the one that is more reactive would be the one to replace or displace the less reactive metal in an equation, such that in the product it's taking the place of the less reactive one. So that's what zinc is doing here, because in the reactivity series, zinc is more ahead, is at the top of copper. Okay, so just a quick one. This is the reactivity series. We have potassium, we have sodium, we have calcium, magnesium, aluminium, zinc. Okay, then it's a trend. So this is how you just have to know it. It's just like knowing the place of each element on the periodic table. Okay, so it's something you just have to memorize. Lead, hydrogen, copper, silver, and gold. You can see copper is far away, more like compared to zinc. Zinc is more like 1, 2, 3, 4, 5, 6th position, 7, 8, 9, 10, compared to copper that is in the 10th position. So zinc will tend to displace copper in a displacement reaction. Okay, so that is for this. But this is not part of the question, just to explain how zinc is replacing copper. Now the next question says, write an equation for the reaction. Okay, for the reaction between zinc and copper 2 sulfate. So an equation for this would just simply be our zinc reacting with copper SO4, which is a solution, so it will be in the aqueous state, and our zinc will be in the solid state, to give us zinc SO4, zinc sulfate. So zinc has replaced copper, displaced copper, okay, plus copper. Now the next question would be, state the type of reaction which took place in 1C. Okay, so that reaction is called a displacement reaction. Next question says, state two gases which should be prepared in fume chamber. Now, the gases that are prepared in a fume chamber are toxic gases, okay, that you would have to be cautious of the fumes that can be produced from it. So these chambers help to protect the person carrying out or handling these gases. So an example is chlorine gas, okay, and hydrogen sulfide, okay, chlorine gas and hydrogen sulfide. Now the next question says, say three factors that favors cracking. Cracking has to do with breaking down larger molecules into smaller molecules through the use of heat. So three factors that would favor this process would be high temperature, because we are talking about the use of heat, high temperature. Cracking doesn't only use heat, it also makes use of a catalyst. Catalyst also would favor cracking. And lastly, low pressure. Now, the next question is, give the reason why noble gases are chemically inert. Noble gases are the elements we find at the end, okay, or the farthest right of the periodic table. Okay, so they are like the last group. So in a representative periodic table, it is the group 8, while in a fully complete periodic table, that is the group 18. Okay, so they are called noble gases because they are stable. And when you're drawing their structure and their electronic configuration, there is no valency there. They have a zero valency because their last shell or their outermost shell is completely filled. So what we can write here is noble gases are chemically inert because their outermost electron shells are completely filled. So the gases we are talking about here, gases like helium, argon, neon, these are the noble gases, completely filled, making them stable and unlikely to gain, okay, to gain, lose or share electrons. So that's why they will hardly be found in bonding process because they are already complete. They don't need to gain like metals or lose like non-metals. They don't need to gain like non-metals or lose like metals rather. Okay. So state four properties of homologous series. That's the next question. Number one, we say all members of the same homologous series share the same general formula. Okay, so for example, alkanes are CnH2n plus 2, alkene CnH2n. So that means every member of alkane family will use that formula to get their own molecular formula. Okay, so number two, we can say each successive member differs by the addition of a CH2 group. Okay, so the difference between methane and ethane is a CH2 group. Difference between propane and butane is a CH3 group, a CH2 group. Okay, so when we're talking about successive members, we're not talking about the difference between methane and butane, for example. They are not following each other, so they are not successive. Okay, now the third one is all members can be prepared by the same general method. Okay, that's because they have the same functional group. So it means that they can be prepared by the same general method. So the last one is the members of the same series shares, or we can say have the same chemical properties. And once again, that's because they have the same functional group. Okay, so the next question is what is global warming? Global warming Global warming is the gradual increase in the Earth's temperature, okay, due to greenhouse gases. Okay, so it's how the Earth maintains its warmness, okay, due to these greenhouse gases. Now the next question is state one cause of global warming, burning of fuels. Fuels containing carbon oxides, okay, and other greenhouse gases. Okay, so question two says define each of the following terms. The first is deliquescence. Now, this is the phenomenon whereby some substances tend to absorb so much water from the atmosphere. That they dissolve in it to form an aqueous solution. Okay. So the liquescence is just about absorption of water. Okay. Why efflorescence is the phenomenon whereby now these substances already have so much water in them, they're already hydrated. Okay. Hydrated substances hydrated substances such as salts when exposed to the atmosphere lose all part of their water of crystallization. To form a lower hydrated or anhydrous salt. Okay, so the liquescence has to do with substances that want to absorb water, okay, from the atmosphere. So they become aqueous. That is a solution that has been dissolved or mixed with water. Now, efflorescence is a phenomenon where something is already hydrated, is already having so much water in it, and so it's exposed to the atmosphere, losing its water and drying up somehow, losing its water of crystallization to form something that is less hydrated. So they're almost like doing the reverse. Now, the next question is give one example of a substance that undergoes each of the processes. Now, for the liquescence, okay, an example is calcium chloride. And the salts, right? These are properties of salts. Then the fluorescence, an example is these crystals of salt. Okay, so these sodium triisocarbonate crystals or hydrated sodium triazo carbonates. Now, the next question says, what is meant by ionization energy? So, ionization energy is the minimum energy needed to completely remove a valence electron in its ground state. Okay, from an isolated atom. In the gaseous state to form an ion. Okay, so the energy that is required for electrons to be removed from valence electrons of atoms. Okay, now the next question says the second ionization energy value of sodium is greater than the first. Okay, that means the second energy that will be required to remove the second electron after removing the first electron from sodium is higher. Okay, now briefly give an explanation of this observation. So what we can write down for this is the second ionization energy, okay, of sodium is greater than the first because after losing one electron, sodium forms a stable noble gas configuration. Okay, sodium is now going to be sodium plus because it has lost one electron and now is no longer 11. Number of electrons is now 10 number of electrons, which is like neon, the noble gas. So removing a second electron requires breaking into an inner shell, okay, closer to the nucleus, where the electron is more strongly attracted or attached, okay, thus requiring more energy. Okay, so it's more like we know that the valency of sodium is 1, okay? So it's easier to um break the attraction there and lose that one electron than for you to start going to be touching the 8 that is in the inner shell. Okay, so we have these as the configuration of sodium. We have 2 here and we have 8. And the last energy level is just having just 1 in it because it's sodium. Sodium is 11 altogether. So it's easy for sodium to lose this 1. When it loses it, it becomes 2 and 8, just like neon. So losing this first one, it requires first ionization energy, okay? But when you are now going to attack this other energy level or the second shell, it will require so much more energy because sodium is already stable at this point. So going to tamper with the next energy level will require much more energy to happen, okay? So that is the summary of what is happening here. Now, the next question says, state Charles' law. Charles' law says that the volume of a fixed mass of gas varies directly with the absolute temperature. So ensure that your temperature is written absolute temperature, not just temperature, but it has to be absolute temperature, provided the pressure remains constant. Okay, so this is what Charles' law states. The next question says, sketch a diagram to illustrate Charles' law. So we're going to have a graphical sketched graph. So this is our axis for volume. Volume could be in decimeters cube or in liters or even in centimeters cube. Okay, and then we have our temperature. Okay, in Kelvin, in decimeters cube. So since our diagram is extending from this negative side, this would be minus 273 degrees Celsius. And then for this diagram, our temperature would be in degrees Celsius. Okay. Now the next question says, a gas occupies 150 degrees, 150 centimeters cube at 210 degrees Celsius. What will be its volume if the temperature is raised to 450 degrees Celsius and the pressure is kept constant? So whenever we see pressure being kept constant, we know that we are dealing with Charles' law. Okay, so on the expression, the formula for Charles' law is the initial volume divided by initial temperature equal to final volume divided by final temperature. Okay, where V1 is what is giving us there, 150 centimeters cube, and T1 is giving us to be 210 degrees Celsius. But I told you it has to be in Kelvin. So for us to make it Kelvin, we're going to um, add 273. Okay, so conversion from Celsius to Kelvin is going to be degrees Celsius plus 273 is equal to Kelvin. Okay, so this is going to be 210 plus 273. Okay, so when we add these together, we would get 3. Okay, and the V2 is what we are looking for, and then T2 is giving us to be 450. We have to make this in degrees Kelvin, in Kelvin rather. So this will be 450 plus 273. Okay, so this will give us this will give us 723. Okay, so imputing it into the equation, we'll have 150 divided by T2, 483, okay, equal to V2 divided by 723. So from here, we would cross multiply, so we have 483 V2 equal to 150 times 723. So our V2 is equal to our V2 is now equal to 224.5 centimeters cube. Now the next question says, write the chemical equations to illustrate what happens when each of the following oxides is dissolved in water. Now the first one, we have sodium oxide. Okay, write down our sodium and then our oxygen. Now we know that by the time we do the crisscross method, in writing this formula, oxygen has the valency of 2, which will be given to sodium, and sodium has the valency of 1, which is given to oxygen. So this is the formula for sodium oxide. Now when this reacts with water, H2O, it would give us sodium hydroxide. Okay, so for us to be able to balance this equation, we have our sodium here and sodium here. We have to make this one balanced, and we have H2O. Okay, our hydrogen is 2 in the reactant and 2 in the product, and also our oxygen is 2 in the reactant and 2 in the product. Now the next one is phosphorus 3 oxide. The 3 there tells us that we are having 3 oxygen. It tells us the number of oxygen, right? So phosphorus and 3 oxygen. Okay, now the valency of oxygen is 2, which will be given to phosphorus. So this is the formula for this. Reacting with water, it will give us this acid. Okay, so now to be able to balance this, our phosphorus is 2 in the reactant, so we have to make it 2 in the product by adding the coefficient. Okay, and then our hydrogen is 2 in the reactant, but in the product it is 6, so we have to also make it 6 here by adding 3. And then our oxygen in the reactant, it is 6, and in the product it's also 6. Now the next one is chlorine 7 oxide. We have our chlorine and we have oxygen. Now the 7 there tells us we have 7 oxygens. So we put our 7 here. And the chlorine there, the valency of oxygen is -2, right? So chlorine is going to adopt that 2. So this is our chlorine 7 oxide plus water. So when these two react, we would get Okay, we'll get this. The next thing is for us to be able to balance our equation. To balance our equation, we have chlorine in the reactant is 2, but in the product, chlorine is just 1. So we have to make this 2. Okay, so now chlorine is balanced. Our hydrogen is 2 in reactant and 2 in the product. And then our oxygen in the reactant is 8. And in the product is also 8. Okay, so we have gotten that our chlorates correctly. And the next one is magnesium oxide. We have magnesium and we have oxygen. So the valency of oxygen is -2 and that of magnesium is +2. So 2 is canceling out 2. So we don't have any subscripts here. Okay, plus H2O. Okay, this is going, since it's metal oxide, it's also going to give us a base, just as the first one. Okay, so we have magnesium OH, magnesium hydroxide. And if we look at this very well, it's already balanced. Now the next question says, arrange the solutions in 2D in the order of increasing acidity. Okay, so we're dealing with sodium oxide, phosphorus 3 oxide. So between these ones, okay, which one is least acidic and which one is more acidic, right? So we know that metallic oxides are basic, while non-metallic oxides are the ones that are acidic. Okay, so what will be our greatest here will be chlorine, because chlorine is the most non-metallic here. Okay, followed by phosphorus. Okay, then followed by magnesium and then sodium. Sodium is very metallic, and so it will give us a very basic oxide, followed by magnesium. Magnesium is also metallic, but not as metallic as sodium. So for us to be able to write this properly, we would have our sodium first, okay, which is less than magnesium oxide, okay, which is less than phosphorus 3 oxide, which is less than chlorine. Okay, so this is the trend, or we can just write it in full word. Instead of writing the formula, you can write sodium oxide less than this. So however you want to write it down. We see the trend is going from metallic to non-metallic. So the non-metallic is the one of highest acidity potential, or the one that is more acidic. And sodium, which is beginning it, is less acidic. So that's why we are using the less than symbol. Now, the next question is write the balanced chemical equation for the production of lead 2 chloride by direct combination. So by direct combination, we have lead, which is Pb, combining directly with chlorine to give us lead chloride. This is just straight to the point. Now, the next is double decomposition or double displacement. Now, what happens in double decomposition? We can have something like this, NO3, 2 of it, plus sodium chloride, okay, to give us lead chloride plus sodium NO3, okay, and this would have a 2 coefficient and 2 coefficients so that it will be balanced. Okay, double decomposition is double displacement. It's more like a positive hand taking the negative hand of the other compound, and the positive hand taking the negative. So it's they are just displacing each other. Now, this is not based on reactivity. Okay, we can see from the reactant to product, lead took the place of sodium. Okay, and sodium took the place of lead. So they are just switching place. One metal is taking the place of the other metal. One non-metal is taking the place of the other non-metal. Okay. So the next one is displacement reaction. So by displacement reaction, take notes and remember that we are dealing with production of lead-2 chloride. So our products must have lead-2 chloride, which is PbCl2. Okay, so the last one is going to be lead reacting with something like copper chloride, because we're talking about displacement reaction. So we have to have, since lead is a metal, we have to have two metals there. So another transition metal like it, probably, to give us lead chloride plus copper. This is displacement reaction like we did earlier. Okay, lead taking the place of copper because it is more reactive than copper. So we can't do the same thing for, instead of using copper chloride, we can't use sodium chloride, for example, or potassium chloride or zinc chloride because these elements are more reactive than lead. So we have to use a less reactive element than lead. We can use copper chloride, we can use silver chloride or gold chloride. Okay, copper chloride or silver chloride because they are less reactive than lead, so they are going to be easily displaced by lead. Now, the next question is state one condition that would increase the rate of reaction for each of the reactions stated in 2A. So one, we have increased temperature. Okay. And the next one, we have increased concentration and increase surface area. Okay, now the next question said, consider the following chemical reaction in equilibrium. Set two conditions that would increase the yield of SO3. Okay, now for this reaction, first off, we are saying that the product is endothermic because it's giving us heat change that is positive. So that is to tell you that moving from the reactant to the product, if it is endothermic, okay, it means that it's requiring high temperature, okay, for us to yield SO3. So say high temperature. And also looking by how many total pressure in the reactant and the products, okay, the reactant is more than that of the product. So we need high pressure as well. Okay, now the next question says, if 60 centimeters cube of SO2 reacts with 40 centimeters cube of oxygen, determine the volume of the residual gas, okay, that is the gas attached to it, or the remaining gas. Assuming that the reaction goes to a completion in a cylinder. Now we are still dealing with SO2 reaction, okay? Sulfur oxide reaction. So based on the equation that we saw earlier, we see that we would require two copper 2 oxide and one oxygen to give us our product. Okay, so 2 moles of SO2 and 1 mole of oxygen. So the ratio in that equation is 2:1. Okay, judging by that, we see that our volume, the volume given to us is SO2 is giving us 60 centimeters cube, and oxygen is giving us 40 centimeters cube. But then, based on the ratio in a proper balanced equation, it's supposed to be 2:1. So if SO2 is giving us 60 centimeters cube, okay, if we're using this 2:1, our oxygen is supposed to give us 30. Because when we say 2:1, 60 will give us what? 60 is normally going to give, when we cross multiply, we have 2 unknown equal to 60. So divided by 2, the unknown will be equal to 30. Okay, so that this is just a side note. So our 60 centimeters cube is supposed to give us 30 centimeters cube. Okay. So this one now is based on the balanced equation. This one now is based on the balanced equation. Okay, but that is to say, what is added up there is going to be our residual gas. So how we went from 30, which is supposed to be, okay, to being 40 is what we are going to do. So this is based on the num or rather based on the moles in a balanced equation. Okay, so this is so now our residual gas will now going to be what we got minus what was supposed to be. Okay, so it's equal to 40 minus 30 is 10. Okay, so our answer is going to be 10 centimeters cube. 10 centimeters cube. So our residual gas is 10 centimeters cube, okay, of oxygen. Now the next question is, what is the change in the oxidation state of sulfur in the reaction 3B? Now when we see the reaction, we have SO2 in the reactant and we have SO3 in the product. So if we are dealing with change in oxidation states, we have SO2, the oxidation state of sulfur in SO2 and SO3. Now in SO2, to find the oxidation state of sulfur, we don't know sulfur, so sulfur is going to be, it is going to be S plus the oxidation state of oxygen is -2, and since we have two oxygens, it's -2 times 2, okay, equal to 0. This is going to be S, this is now going to be S minus 4 equal to 0, okay? This will now is now going to be S equal to plus 4. Now for the second one, S is plus oxidation state of oxygen is -2 again. But since we have 3 oxygens, so -2 times 3 equal to 0. So this will give us x minus 6 equal to 0. And this will give us S equal to plus 6. So it went from plus 6 to -6. So the change is the difference between two things. So the change is now going to be 6 minus 4, which is 2. So our change is going to be plus 2. Okay, now the next question says, using structural diagram, explain why cyclopropane is not an isomer of N-propane. So that means we'll have to draw. Okay. Now cyclopropane is, we have C, we have another C, and we have another C. Triangular shape. So we have to draw this H and H. This H and H. Okay. And these are H and H. So this is cyclopropane. Okay, so this is our cyclopropane. And then for N-propane, N-propane is 1, 2, 3. That is normal propane. Hydrogen, 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 hydrogen. Okay, so we'll label it N propane, and we'll label this cyclopropane. Now, our cyclopropane is C3, how many hydrogen? H6. And our N propane is C3H8. Okay, now over to explaining why they are not isomers of each other. They both have different molecular formula. Okay, and for two things to be isomers of each other, they must have the same molecular formula or different structural formula. Okay, but that's not what we are saying here. So we can just write a note and say cyclopropane and N-propane are not isomers of each other because they have different molecular formulas. Okay. Now the next question says a structural organic compound X containing 3 carbon atoms reacted with butanoic acid in the presence of dilute H2SO4 to form a sweet-smelling compound Y. Okay, so in this kind of reaction where in the presence of H2SO4 and we are seeing butanoic acid, so this is likely going to be an esterification reaction. So since we were told X is containing 3 carbon atoms, it's going to be a pro, and it's going to be propanol. Okay, propanol. And our Y is going to be a propylbutanoate. So the next question says, state the functional group present in X. So we can see it's an alcohol, and the functional group is the OH group, which is called hydroxyl group. Okay, now the next question is write an equation for the reaction between X and butanoic acid. So our equation for that reaction already is going to be C3H7OH plus C3H7COOH. Okay, to give you C3H7COO, C3H7 plus H2O. Okay. Now the next question is write a balanced. This is an esterification reaction for the 3CIII. Okay. Then the 3DII. This one we just did now. The next question is 4A. Write a balanced chemical equation for each of the following reactions. So we have ammonia gas with copper 2 oxide. So ammonia, this is ammonia. Okay, plus copper 2 oxide. Now this is going to give us the nitrogen gas plus our copper plus water. And in balancing this equation, our nitrogen is not balanced, so we have to balance it this way. Okay, our hydrogen is also not balanced, so we have to make it 6 in the products by adding a 3 here. Our copper is balanced and our oxygen is having, we have 3 oxygen in the reactant, so we have to make it 3 in the products, and so our copper also will be influenced here. Now the next question is ammonia gas with oxygen gas. So ammonia again, okay, reacting with oxygen. So in this case, we are having NO, okay, nitrogen oxide plus water. And in balancing this, we have to balance our hydrogen. So to balance this, we're going to have 4 here, we'll have 5 here, we'll have 4 here, and 6 hydrogen. Okay, this is H2O. Now the next is potassium iodide with chlorine gas. So we have potassium iodide plus chlorine to give us potassium chloride plus iodine molecule. Okay, so to balance this, we'll do the same thing. Because of the iodine, we're going to have 2 here, and our chlorine will be chlorine 2, then our potassium will also have 2 here. Now the next question is ion with dilute tetraisosulfate 6. So we'll have our ion F2Fe plus H2SO4 to give us our iron sulfate plus hydrogen. You can see this is a displacement process. So what would happen here is our iron is balanced, our hydrogen is balanced, and our SO4 is balanced. So we don't have to have any coefficient. Aqueous. Aqueous lead triazonitrate, lead 2 triazonitrate. So we have our lead here, Pb. This is triazonitrate, 2 of it because of the oxidation state of the lead, plus 2 HCl to give us lead chloride plus 2 HNO3. This is just the overall balanced equation. Now the next question says, describe briefly the process involved in the extraction of tin from tin ore. Okay, so we would say tin is extracted from its ore. The ore is cassiterite. This is the ore. Now the ore is first crushed and powdered. Then it is concentrated by gravity separation. Okay, to remove larger impurities. Okay, to remove larger impurities. Now the concentrated lead ore is then heated. It is heated with carbon, form of coke, in a furnace. Which reduces the tin oxide into metallic tin. Okay. Now the molten tin is collected and then it is cooled and passed through cast process of extraction. Okay, so for higher purity, that is to get just the tin this time around without anything attached to it or any oxygen or any oxide. The tin can be refined. Okay. So we can also write a complete equation for this process. To carbon to give us tin plus R2CO. Okay. Now the next question says, mention 3 uses of hydrogen. Hydrogen is used in the production of ammonia. Okay. During the Albert process. The Albert process is the process used in making ammonia. Now, another use of hydrogen is it is used in the hydrogenation of vegetable or vegetable oils. Okay, that is the process that converts unsaturated fats to saturated fats. Now, the third use, okay, hydrogen is also used as a fuel in rockets and fuel cells. Okay. Now the next question says, state 2 physical properties of hydrogen. Hydrogen is colorless and hydrogen is odorless. The next question says, state the class of oxide to which each of the following compounds belong. So we have sodium oxide. Sodium is a metal. Okay, and earlier I said metallic oxides are basic oxides. Okay. And the next is zinc oxide. This is an amphoteric oxide. Okay, both acidic and basic in nature. It has the property of both. And then we have sulfur 2 oxide, which is acidic because sulfur is a non-metal. And then we have carbon 2 oxide. which is also acidic. And then we have a neutral oxide here. Okay, the nitrogen oxide. Now, number 5 says write the chemical formula for alumina. So now this is alumina. In the extraction of aluminium, state one compound that is used, one, to obtain alumina from bauxite. Okay, so here we have sodium hydroxide. Then the next question said that is used, one compound that is used as a solvent for alumina. And that is the cryolite, which is sodium 3, aluminium, and fluorine. Okay, so cryolite. Now, the next question is name the electrodes used in the extraction of aluminium. So for this process, we have carbon. Okay, or we can say the graphite. Graphite is carbon, so carbon electrode. Now give one reason why the extraction of aluminium is expensive. It is expensive because it requires, okay, it requires large amount of electricity. Okay, then in the extraction of aluminium, name the substance liberated at the anode. The substance liberated at the anode is oxygen. Okay, and write the equation for the reaction that leads to decrease in the size of the anode. Okay, so the equation is carbon from the electrode, then oxygen to give us CO2. We can see that in this case, the anode is where the negative charge, okay, the negative ion is going towards, and that is why we have oxygen there. Okay, then aluminium is now going to the cathode. Now the next question says, give two ions that cause hardness of water. We have calcium ion, and then we have magnesium, magnesium ion. So you can either write it like this, or you write it in, say, calcium ion, magnesium ion. Then the next question says, state two advantages and two disadvantages of hard water. So advantages. One advantage of hard water, hard water contains calcium and magnesium. Okay, which are good for the bones. Now, another advantage is that it is useful in some industries. Okay, in some industrial processes, such as in brewing. Then for our disadvantage, hard water ladders. Rather, it's hardly ladders. Disadvantage. One disadvantage, it is hard to ladder. That is, it is hard to form, to give foam. Okay, to be soapy. So you have to use so many soaps in it for you to be able to get all the foaminess from a soap that you want, making washing difficult. So making washing with a hard water difficult. Now the second one is causes scaling in pipes. Okay, and boilers, reducing their efficiency. Now, the next question says, what is meant by destructive distillation of coal? Okay, destructive distillation of coal involves heating coal to a very high temperature. In the absence of air, producing four products. Okay, which are coke, coal tar, coal gas, and ammonical liquor. Now the next question is, name four products obtained from destructive distillation of coal. Just what I mentioned. So we have coal, we have coal tar, we have ammonical liquor, and also have coal gas. Now the next question says, name two gases which can be used to demonstrate a fountain experiment. So we have ammonia and hydrogen chloride. The next is give the reason why the gases named in 5DI above are used. They are used because they are highly soluble in water. Okay, so causing the fountain effect. Okay, so that's all we have for today. Bye bye.